Oblivion. It's actually really weird when you scan the internet now. It appears there's a bunch of firewalls out there with a little mess with Kaminski switch, and people are checking it off. No, you can't just send a bunch of sins at a whole bunch of IP addresses and expect that the boxes that speak back to you are actually there. They lie a lot. That being said, I've been trying to filter through the data I got back, and I've gotten some interesting things out of SSL servers. There are two basic rules for deploying SSL. SSL is supposed to give you a nice encrypted session. First of all, on the public component of an SSL cert, do not put anything you would not want to actually be public. There's a reason it's called a public key. You would think this is obvious. Gee, no one's going to go out to every IP address and look at all the certs to see what's in them. The other thing is you really can't put the same certificate in different boxes. That's because SSL doesn't have this one property called perfect forward secrecy. If box A and box B had the same private key, they can read each other's traffic. Now, this shouldn't be a problem because by crypto theory, you never move private keys. You always generate a private key on the box that's going to use it. You know, bits are cheap, as Bruce Schneier said. So this shouldn't be a problem either. No one would ever go out and look to make sure no one's been copying their keys all over the place. Actually, we did that and totally found it. Speaking of that whole public key thing, if you are the sort of site that does not want people... if you put out a honeypot, and this honeypot, its goal is to trick people into attacking it, you might not want to call it honeypot.yourcompany.com. But if you do, you might want to put that in the SSL cert. It's kind of signed, "Hi, I'm the honeypot." Yeah. What about the other stuff in terms of keys leaking all over the place? Well, here's what's good. 90% of the SSL keys that I found were actually on only one box, just like the spec said. Excellent. 10% of the keys were a little more widely deployed. So widely deployed, in fact, about 1 out of 3 boxes on the internet that's hosting SSL actually has a unique key. This is called when things go bad, things go really, really bad. There's like a whole bunch of VPN concentrators and embedded devices that, well, you buy one on eBay, and then you can read all the traffic the other ones move. There's some groups that really should know better that have deployed like 10,000 machines or so. If you work at this group, yes, I'm talking to you. The absolute numbers are pretty sketchy, though. Like I said, there's a bunch of boxes that are messing with me, but there's a lot of devices out there that got sold. To their credit, there's a couple companies that are doing things correctly. I can specifically say, you know, Cisco and HP both clearly have devices that, you know, they'll have the same template, but clearly when the first time you boot up the machine, they actually generate cert at that time. So that's kind of nice. And you can just see it because they have the same template, but the keys are different. So Cisco and HP, at least for a couple of the devices, have done the right thing. A couple other devices have very, very much not. Online banking. The world's most depressing Google search is, "Why is this secure?" How about instead of telling me, "Why is this secure?" how about you actually be secure? It's depressing, you know, like 26% of the top 50 banks, they do this, "Hi, I'm going to give this to you on a web page, and it's a username, password, oh, excuse me. Here's your social security number from a couple sites." And they're not asking for it from a SSL encrypted site, no. But they are putting down a GIF of a lock. The incredible thing is, you know, they paid some absurd amount of money for this collection of pixels. Everyone does the same thing. It's hilarious. Why is this the case? Why aren't they... So the reason this is insecure, of course, to get any of these logins over HTTP, the idea is that they post to HTTPS. If there is no bad guy, you will indeed securely log into the website. In the absence of an attacker, you are safe. Okay, in the absence of the attacker, you are already safe. The whole point of security is secure in the face of an attacker. So why aren't they just encrypting every single connection to the bank website? Well, there are a few banks that do. Wells Fargo comes to mind. And as soon as you go to wellsfargo.com, bam, you are instantly moved to an HTTPS site. Why doesn't every bank do this? Don't they have all the money in the world? Well, you know what? It is a pain in the ass. It is expensive. It is not very scalable to have every single access to your website come in over SSL. Security people believe that it is. We're wrong. It sucks. SSL hardware does not scale worth anything. And so basically the perf guys say, you know what, we're just not going to have every link be SSL, sorry. There's another possibility, and this is done about 50% of the time. This is actually really common. Or what they do, actually I need a clock on me because I was spending a little bit more time here. 12:48, I'm doing just fine then. So here's another option. There are a bunch of banks that do that. When you go to their homepage, what they show you is not, here's username, here's password. Instead, they say, please click here and we'll let you log in. We'll move you to a site now that will let you log in. This works. Lots of banks do it. Here's the problem. The UI guys veto it. They say if you don't give people a username and password prompt on every single page, either A, they don't know online banking exists, or B, they're not being told to go ahead and use it and stop calling us on the frickin' phone. Your bank does not want to talk to you. They want nothing to do with you. They want your money, and they want you to come into their computers and tell them what to do with it. They don't want to talk to you because that's expensive. So the UI people say if we go ahead and we don't have this form on the front page, people aren't going to use online banking. We're going to have to spend more money talking to them on the phone. So the perf guys vetoed always be secure with SSL. The UI guys vetoed go into a second page. And so you have the third option, which is crap. And the security guys lose. Security people do actually lose if they don't be realistic about what's going on and about what people's requirements are. So here's a question. Can we make everyone happy? Can the user interface guys be happy? Can the perf guys be happy? And shockingly enough, can security be happy too? The answer is yes. So here's what we're going to do. Web pages are not actually static. These are not, like PDF. No, PDF's a bad example, but they're not like a sheet of paper. They're actually little programs. You can throw JavaScript in there. They can recode themselves in response to user input. Now, there's a mechanism in HTML called iframe, which is basically putting a mini window of another site inside of a page. Now, it's well known that you can use iframes to pre-cache an entire web page. Like, if you know click from page A to page B, while they're viewing page A, you can have a miniature iframe load up page B. So as soon as they click, it goes to the cache contents, pulls it out of the web cache. Great, wonderful. What wasn't very well realized is that you can actually put an SSL site into an iframe. So you go to a website, and it will, in the background, even though it's an HTTP link, it will, in the background, start up the SSL session, start downloading, start caching, all while you're browsing normally. You can actually do this. So here's what you do. Here's how you combine these two things. Conceivably, the username on a banking site is not particularly private information. If it is, then it shouldn't be in plain text. It should be X'd out in case you're, in some place someone can look over your shoulder. While the user is typing in their username, the web page can, because it's dynamic, because it's not static, because it can recode itself, the web page can actually go ahead and insert an iframe while typing name to receive that causes the page to start up the SSL session. And when the user goes to type in the password, they're just instantly moved over to SSL then. Now, this has actually been implemented. The way it ends up looking is you type in your username, and as soon as you start typing, I have this iframe coming up over SSL from Yahoo. Yahoo is actually another site that messes this up. The online banking guys I can understand because, tech really isn't their thing. But come on, it's freaking Yahoo. They should know better. So the idea is you need to log into something. You start typing in your username. As soon as ABCD went in, as soon as literally I hit the first character, it spawned this iframe. And then the moment I go ahead to actually click on password, it actually doesn't let me insert any text. It goes, this is not a safe place for text to be inserted. It moves me over to SSL. look like in code. It's really straightforward. It's just a form that has a on focus. As soon as the password gets the focus, it moves the location over to the HTTPS site. It's actually fairly elegant. So perf is happy, UI is happy, and dear God, we're actually not being ridiculously insecure. Woot. So, as long as we're talking about bugs in crypto systems, 2001, one of the things I found out is that SSH can be used to do kind of a poor man's VPN. SSH is traditionally a system for getting a shell on a remote machine, a command prompt. And they had a little bit of functionality that said, oh, if I've got some like web server running on here, or I've got an email server, we can do something called port forwarding. But I want you to say, when you do the initial connection, what all your port forwards are going to be. And so people would have these horrible scripts and would try to map these things. It was such a pain in the ass to manage. And I was like, wouldn't it be nice if every time we needed a port forwarding, we could just say, okay, this time I wanted to go here, this time I wanted to go here. Well, it turns out there was a protocol already supported in all the web browsers and all the various tools called SOCKS. And SOCKS let you declare to SSH, hey, I'm going to connect to the machine over there, and I'm going to go ahead and connect on this port, and I want to go to Yahoo. I want to go to CNN. And I want it to work, same connection, same syntax. In fact, I want it to be like I'm sitting on that network over there. And this is great, and this is wonderful, and there's a little tiny problem. You see, a few years after I did SSH, I did some DNS research. And DNS, of course, is what you use to convert from yahoo.com to some IP address. Well, when you're using SOCKS, at least SOCKS 4, what you do is locally, you say, hey, what is the number for Yahoo? And then you take that number and you remotely go over the SSH link and you go places. What was it about earlier about being, security when there is no attacker is not that useful? You want security when there is an attacker. An attacker can actually, on the local link, hijack your outbound DNS. And even though your packets are going out over some foreign link, locally the bad guys can redirect how things go foreign. So we need to get DNS to happen remotely. About a year and a half ago, I got SSH to support the SOCKS 5 protocol, which does indeed getting the remote host to do all your addressing for you. The problem is that the browsers, Mozilla does actually support SOCKS 5 through a hidden setting. Thank you. Internet Explorer, not so much. We'll leave it at that. Is it possible for us, even for these clients that aren't supporting SOCKS 5, is it possible for us to suppress the leakage of DNS data? Yeah. So, SSH. Okay, so I was talking earlier about TCP, right? TCP being our standard way of doing a reliable communication from point A to point B with bandwidth and all the other stuff handled. DNS does not go over TCP, normally. Normally, DNS goes over UDP. UDP is basically, I fire a packet and forget about it, and oh, maybe something will come back later. We could put a UDP to TCP translation layer in SSH that just handled DNS, and then, write all this code, and then be a whole bunch. Or, it turns out, for various obscure reasons, DNS actually does run over TCP as well. It needs to get back a packet that says, yeah, I know you tried to do that over UDP, but no, you better retry that over TCP. So if you actually put up a fake server that sets what's called the truncation bit, and you have it respond to every request with the truncation bit set, your client stack will actually retry over TCP. And now you can go ahead